Hello, my name is Beckett Socha, and this is Lab 5, the Random Choose Your Own Adventure lab. Okay, starting off with a table of contents for what I have in the lab presented today. I've got the introduction, equations, recap, the code I used, the results, and the conclusion. Okay, so for a brief introduction of this lab, you get to choose to do anything as long as it relates to what we've learned in physics. So I chose to simply test the energy principle in Newton's second law just by dropping a die and tracking it using the tracker. You can see this shot photo of me. So we determine the forces and energy upon a falling object, which is the die. Fundamental principles, like I mentioned before, was Newton's second law and the energy principle. And it's important to study because it helps us determine how energy works in real life in situations like this, and it displays how Newton's second law is incorporated in different forces. Okay, so here is a recap of our previous equations, which is Newton's second law is just F net equals ma, and then also it shows momentum principle in there as well. And then there's also the force of gravity, but because we're on Earth, it's just mg. If it was on a different planet, it would be that. And then the energy principle is delta E equals the work surrounding plus Q. And that can be rearranged in different ways if energy is conserved or not, which in this case it isn't. Okay, so here is the initial conditions for the glow script code that I had, which shows the initial mass position, the velocity of the die. And I used these initial conditions to put into this part of the code. So pretty much just to summarize what all of this is, all these are a series of equations that help calculate the drag and the total force. So on the left side here, you get your equations for potential energy and the kinetic energy as time goes. And then you can plug that back into the energy principle equation, which I have later. And then this is just for the forces to get the F net, which you can use for work, which is also in the energy equation. Okay, so here is the results of my lab. After concluding the experiment, my observed results were pretty similar to the glow script model. I didn't incorporate the tracking photo, or yeah, the photos of the tracking, but the actual this line right here shows the results from the tracker, and it's pretty similar to what happened over the glow script code. And then also with the energy graph, you can see that this is perfect because the potential energy and kinetic energy add up to 0, obviously, and as the die fell, it increased in kinetic energy and lost potential energy. Okay, so brief conclusion. What does this mean? It's just a display of energy conservation and the energy principle. It's great. Gravity works. Newton was right. And then some other questions. If I threw the die up, or threw the die out instead of dropping it, same scenario, right? Because I'm throwing it out outwards, gravity is still acting upon it in the y direction, so my numbers would come out exactly the same. And if I threw the die up, rather than just dropping it, the only thing that would change is that initially the kinetic energy would decrease as it went upwards, and the gravitational potential energy would increase as it went upwards, and then the inverse would happen as it fell. So just minor differences. So yeah, that's all for physics, I guess. Take care. Have a good one.